Hey guys, this is Professor Janacek, and I want to go over an example of working with differential equations. Here we have two drivers. Ali and Brett are participating in a race. Beginning from a standing start, they each proceed with a constant acceleration. Ali covers the last 1/17th of the distance in 5 seconds, whereas Brett covers the last 1/5 of the distance in 17 seconds. Who wins and by how much time? To start with, we'll take note that we're working with constant acceleration. So we know that since acceleration is the second derivative of position with respect to time, we can integrate this, and that gives us AT times a constant I'll call C1 is equal to the first derivative of position with respect to time. Of course, we do know that that is velocity. Well, since we're starting at since we begin at a standing start, we know that at time equal to 0, the velocity is also equal to 0. Thus, taking that equation, we have a times 0 plus our constant is equal to 0. Solving this, we get that C1 is equal to 0. Hence, we have that AT is equal to ds dt. And from there, if we integrate again, we get 1/2 AT squared plus another constant, I'll call it C2, is equal to just position. Again, at time equal to 0, we know that the position is also 0. Thus, substituting in, we have 1/2 A times 0 squared plus C2 now is equal to 0. Thus, we can see that C2 is also equal to 0. Hence, we're working with the equation 1/2 AT squared is equal to S. We could actually solve this for T and get that T is equal to the square root of 2S over A. Notice I only need the positive root here. I don't need the negative because we're dealing with time and we're only moving forward through time, not into negative time. All right, so now we have a general equation to work with. Notice this is that time is a function of position. Notice it does also have to do with acceleration, but that acceleration is constant. That is not changing. There will be an acceleration for Ali and an acceleration for Brett independent of one another. However, time here is a function of S. So we could write this as T of S is equal to the square root of 2S over A. All right, so let's first look at what's going on with Ali. So I'll write this Ali's time as T sub A. Looking at the total time, again, it's a function of S. Notice that Ali covers the last 1/17th in 5 seconds. Of course, that means we're going to have to consider what happens with the first 16/17 of the time. But notice that the total time, t sub a, for a Lie is equal to that time function evaluated at the first 16/17 s plus that time function evaluated at the last 1/17 s. Okay, well, we do know that the last little bit, the last 1/17 of the distance, was covered in 5 seconds. So that allows us to write t sub a of s as t sub a of 16s over 17 plus 5. All right, so far so good? Okay, now I'm going to use this idea right here. Since t sub a of s is equal to the square root of 2s over a sub a, notice that the time, I'm looking at just a Lie's time, and I'm also looking at a Lie's acceleration. What we can do then is write t sub a of 16s over 17 as the square root of 2 times 16s over 17 over a sub a. All I did is simply substitute 16s over 17 for s in that original time function. We can actually simplify this just a little bit. I'm going to just factor out the square root of 16 over 17 because check this out, what's left is the square root of 2s over a sub a, which ends up being just the square root of 16 over 17 times, check this out, this bit right here, that's just t sub a of s. How nice. All right, so what does that give us? So here I'm going to go back to this guy, that t sub a of s. What I'm going to do now is simply replace this with what we just found. That right there. Okay, just making that little substitution. We have t sub a of s is equal to, instead of t sub a of 16s over 17, that is the square root of 16 over 17 times t sub a of s plus 5. Now, what good was that? Well, check this out. T sub a of s, t sub a of s, I've got just one unknown amount here. We can solve for that. And we get, let's see, t sub a of s, what would that be? 5 over 1 minus the square root of 16 over 17. Take your time with that, make sure you get all that worked out properly. We can put this into a calculator, and that gives us approximately 167 46/100. All right, so there is our time for a Lie. Let's also take a look at what goes on with Brett. Using the same process, t sub b of s is equal to t sub b of, now notice Brett covers the last 1/5 in 17 seconds. So we're going to actually split this into figure out what's going on with the first 4/5. And writing this, so this is t sub b of 4s over 5 plus t sub b of s over 5. Okay, well, since t sub b of s sub 5, that last 1/5 is equal to 17, then we can rewrite this, making that little substitution. So it's going to be plus 17 out there. All right, so now all we have to do is figure out what this value is. Again, following what we did previously. Whoa, where did that come from? All right, there we go. Also remember, I'm going to now kind of backtrack and use this little formula, t as a function of s. So, oops, that gives us t sub b of s is the square root of 2s over a sub b. Now again, this is Brett's acceleration. Then we know that t sub b of 5s, nope, how about 4s over 5 would be equal to the square root of 2 times 4s over 5 over a sub b. Again, I'll do exactly like I did before. We'll factor out that square root of 4/5 gives us 2s over a sub b, and I really like that I can simply replace with t sub b of s. So we get the square root of 4/5 times t sub b of s, and we are well on our way. Thus, again, rewriting this one right here, all I'm going to do is replace this bit with what we just found. So, t sub b of s is equal to the square root of 4/5 times t sub b of s plus 17. Solve this. Again, what makes this so nice is now I just have this one unknown, t sub b of s. Solve for that unknown. Use a wee bit of algebra in here. And we get t sub b of s is equal to, let's see, what would that be? 17 divided by 1 minus the square root of 4/5, which gives us an approximation of 161 3/100. And that is Kevin's total time. Again, notice what we're getting. So, Kevin, this isn't Brett's total time. This is this t sub b and this t sub a, these values that we're getting, that's the total time for each of them. The total time for Ali is 167.46 seconds. The total time for Brett is 161 3/10 seconds. So looking at that, looks like, actually, do a quick little subtraction. 167 46 minus 161 3/10 is, what is that? Six and 43/100. And let's see, who had the better time? Well, it looks like This 161 is the lower time, so and that's what we're looking for. That's how you win the race, with a shorter time. So it looks like Brett wins by 6 43/100 seconds. And there we go. Enjoy.